Hello and welcome. We are going through SCT Math syllabus topic wise, and in this video we will discuss a topic from heart of algebra, and that is linear equations. The whole topic is linear equations and linear inequalities, but that linear inequalities part we will discuss in another topic. All the related playlist you will get in the description box. Alright, now let's start. Linear equations. So basically I have written some points here, you can see, and once you understand all the points you will have a great idea about this topic. Now this topic is all about these 3 points, but in order to understand these 3 points you need to have a good command on these points. So once you understand these points, that will help you understand the actual topic. Now let's start. Variables and constants. What are variables? What are constants? So, the characters whose values change are called variables, and whose values do not change. For example, 2, minus 1 upon 3, root 6. These are constants. So, variables, constant. Is it fine? Variables can also be represented as S, T, U, V, W, R, P, Q, all these we can use to represent a variable. Sometimes we use A, B, C as constants as well, but these are, main constants. So I hope you have understood what variables and constants are. Now, expressions, polynomials and equations. What are these things? If you combined variables and constants, no matter how you combine them, just you combine them, you will get expressions. For example, 2x plus y, it is an expression. X upon 2 plus 2 upon x, it's also an expression. 7 square root x plus 3, it's an expression. Okay, 1 upon x square plus 7, it's also an expression. 4 upon x plus 3 upon y. All these are expressions. Got it? Even if I just write x, it's an expression. If I just write root 7, it's also an expression. So when we combine variables and constants, they are called expressions. So all these are expressions. Now, what is a polynomial? Well, a polynomial is an expression in which powers of the variables are in whole numbers. Whole number means, when we talk about whole numbers, 0, 1, 2, 3, 4, 5, 6, these are called whole numbers. So power cannot be in fractions or it cannot be negative. We cannot have these powers. We can only have powers in whole numbers. So going with this logic, going with this idea, which of these can be called polynomials? Now, you can now just have a look at these one by one. First, this one. Is it a polynomial? Yes, it is a polynomial because power of x is 1 and power of y is 1. So yes, 1 and 1 both are whole numbers. So it is a polynomial. What about this? Well, if you just look at this, you can say that this is a polynomial, but no, it's not a polynomial because x we have in the denominator. If you take this x up in the numerator, you will have what? 2x power minus 1. And since x has a negative power, it's not a whole number. So it is not a polynomial. It is an expression. All these are expressions, but it's not a polynomial. Similarly, x has power half because whenever we have root x, it means power is half. It is also not a polynomial. Similarly, it's not a polynomial. It's not a polynomial. It is a polynomial. Why? Because x has power 1 here and 1 is a whole number. Now, what about this? Okay, you may say that 7 has power half, but we don't have to look at the constant. We have to look at the power of a variable. And what about variable here? Now you can say that there is no variable here, but if you put a variable and you put its power 0, it can be called a polynomial. You know how? Because variable has power in whole number, 0 is a whole number. So what I'm saying that if you just have a constant, it is also a polynomial. I mean, if you just write 1 upon 3, it is a polynomial. Although it will be called a constant polynomial, that we will come to, we will come to this part later on. But if you just have a constant, it is a polynomial. Okay. So I hope you have understood the difference between an expression and a polynomial. Basically, all the polynomials are expressions, but all the expressions are not polynomials. Got it? Now, what about equations? Well, equation means you are writing something equals to something. If you write 2x plus 3 equals to 7, it is an equation. If you write x upon 2 plus 2 upon x equals to 0, it's an equation. So these are equations. When you write something equals to something, if you write 6x plus 4 equals to 2x plus 9, it's also an equation. So because we have this equal thing here and something equals to something. Well, one more thing you need to understand here, that sometimes you may see polynomial in this shape. P of x equals to x square plus 7x plus 3. So what is this? Is it a polynomial or equation? So you may say that, okay, we have an equal sign here, so it is an equation. No, it's not an equation, because it is just a representation of a polynomial, that we are writing it p of x, but it is not equal to something. In order to convert it in equation, you need to write it equals to something. I mean, it should be equals to like 4 or 5 or 6 or something. Okay, so it is still a polynomial. It is still a polynomial. It's not an equation. Okay, an equation is in this form. So I hope you have understood the difference between expressions, polynomials and equations. Now, degree of a polynomial. Okay, we have some polynomials here and we have to write their degrees. Now, degree of a polynomial is largest power, highest power. Highest power. What is the highest power of a variable? Okay, highest power of a variable. So what is the highest power of a variable here? It is 1. So its degree is 1. What about this? What is the highest power of a variable? Now, highest power of variable is 2. Okay, don't say that it's 4 because it's power of constant, not of a variable. So its degree is 2. What about this? So x is a variable, y is also variable, and its power is 2, its power is 3. But what about the highest power? Highest power is 3. So its degree is 3. What about this? Its degree. What is its degree? Its degree is 1. Okay, its power is 1. So highest power is 1. So degree is 1. What about this? Now, since there is no variable here, it becomes, so we can assume that there is x here, but it has 0 power. So its degree is 0. Keep in mind. So whenever there is just a constant, its degree is 0. But what about 0? When you have just 0, what about the degree of this 0? Its degree is not defined. Keep in mind. Not defined. Okay, so whenever there is 0, just 0, its degree is not defined. Whenever there is constant, its degree is 0. When highest power is 1, now you can see all this. And let's cover this thing as well here, because it has so much to do with the degree. Whenever we have degree 1, such polynomials are called linear polynomials. When degree is 2, these are called quadratic polynomials. So it is a quadratic polynomial. What about this? So since degree is 3, it's called cubic polynomial. What about this? So since here degree is 1, so it's again called linear polynomial. So linear polynomial means degree is 1. What about this? So whenever degree is 0, Such polynomials are called constant polynomials. And when we have degree not defined, so such polynomials are called zero polynomials. Zero polynomial. Okay, so these are various types of polynomials. Okay, now again all these are polynomials. If you are asked what is the degree of this x upon 2 plus 2 upon x, what is its degree? So first you will write this in a proper way. It will be x upon 2 plus 2 and x will go up minus 1. Now you can say that it's not even a polynomial. So its degree doesn't exist because it's not a polynomial. So it's not a polynomial. So its degree doesn't exist. Understand, keep in mind. So when we talk about degree, we talk about only polynomials. Okay, now we have monomial, binomial, trinomial. It's very simple. Very quickly we can cover this. Monomial means single term. So when we have single term like this, terms are separated by plus and minuses. Okay, for example, if this is like, we can write it minus. Okay, these are three terms. These are three terms. So it's called trinomial. These are two terms, binomial. These are again three terms, trinomial. This is single term, monomial, monomial, monomial. So having single terms means monomial, having two terms, binomial, three terms, trinomial, and all these are actually polynomials. Okay. All right, now we have linear, quadratic, and cubic equations. You know the difference between a polynomial and an equation. In equation, we have something equals to something. Now, if you look at this, the first one, if you put, you know that this is a linear equation, a linear polynomial. This is a linear polynomial. But if we write this equals to 0, then this becomes linear equation. If we write this equals to 0, 1, 2, 3, 4, anything we can, but we will not change its highest power. Okay, otherwise it will not remain a quadratic equation. This is its degree. Okay, its highest power is 1. It's a linear equation. Now it has become an equation because now something is equal to something here, and it is a linear equation. It is a quadratic equation. It is a cubic equation if we put this equals to 0 or 1 or 2, even if we put this equals to y square, it is still a quadratic equation. It is still a cubic equation because highest power is 3 here. Understand? If we put this equals to 0, it again becomes a linear equation. So basically you have these things. Okay, you will not have like constant equation or something like that. Linear equation, quadratic equation, cubic equation. Have you understood? But our main focus here is on linear equations. So now we will discuss this linear equation in detail. Okay, so first of all, we have general equation like linear equation. Linear equation in two variables is ax plus by plus c equals to 0. This is general equation of a line. You can clearly see here that highest power of variables is 1, 1, 1. Okay. Linear equation. So this is a linear equation in two variables. We can have a linear equation in one variable. For example, x equals to 5. It is a linear equation in one variable. One variable. If I write x plus y equals to 6, it is linear equation in two variables. Got it? Now we have solving linear equations. How to solve a linear equation? Solving a linear equation. Okay, how to solve a linear equation? So first of all, what is called solving a linear equation? Means we have to find the values of the variables that are in the equation. Well, now you have to keep in mind that in order to solve a linear equation, you need to have number of equations equals to number of, number of variables equals to number of equations. Then you can have unique solutions, distinct unique solution you can have. Unique solution means not more than one solution. So what did I say? You should have number of variables equals to number of equations. So for example, we have x plus 5 equals to 0 and we have to solve for x here. Can we do that? Yes, we can do that because we have one equation and we have one variable. So we can do that. Okay. And after solving, we can have x equals to minus 5. So we have solved for x here. But if we have x plus y equals to 6, can we solve this equation? Well, we can solve this equation, but we cannot find a unique solution. We will have then more than one solutions here. Why? Because now number of variables, we have two variables and we have just one equation. So when number of variables are more than number of equations, then how many solutions we will have? We will have infinitely many solutions. Infinitely many solutions when number of variables are more than number of equations. How can we have infinitely many solutions here? Here we have x plus y equals to 6. So now let's write a few solutions. Well, we will have infinitely many solutions, okay? We cannot write all, but just a few. We have x plus y equals to 6, so y can be 6 minus x. If we put x equals to 1 here in this equation, or we could have put this as well in this equation as well. Okay, so what if, if we put x equals to 1 in this equation, we get y equals to 6 minus 1, that is 5. So the solution is x equals to 1, y equals to 5. This is one of the infinitely many solutions. If we put x equals to 2, we get y equals to 6 minus 2. I am putting in this equation and we get 4. It means x equals to 2, y equals to 4. And clearly you can see that we can have infinitely many solutions. We can put x equals to 100, then y is 6 minus 100 and that is minus 94. So we have x equals to 100, y equals to minus 94. So this is another solution. So understand this concept. So in order to have a unique solution in two variables, we need to have two distinct equations, two different equations. What do I mean by different equations here? Okay, here we have x plus y equals to 6 and x minus y equals to 2. If we have these two equations, we can clearly have a unique solution. We will have x equals to 4 and y equals to 2 here. This is the unique solution. This is the unique solution of this pair of equations, this system of equations. You cannot have more. You cannot have any other solution. This is one and only solution of this pair of equations. But sometimes what they do, they give you equations like x plus y equals to 6 and 2x plus 2y equals to 12. These equations may look different. Well, you can see that, okay, we have two equations, so we can have a unique solution. But no, actually this equation is multiplied just by 2 and we are getting this equation. It means both are actually the same equations. and if you draw a line, you will have the same line overlapping. Okay, one over another, we will have these two lines. If you draw these lines, well, we will draw these lines in graph paper later on. But first understand that when all the coefficients are in proportion, we will have infinitely many solutions. So now we are talking about this particular concept. When we have unique, infinitely many solutions and no solutions. Okay, now if we have two equations, a1x plus b1y plus c1 equals to 0, or we can have this c1 on the right hand side, it doesn't matter. Okay, second equation, a2x plus b2y equals to c2. We have this pair of equations. See, the thing is that in your syllabus you have either equations in one variable or in two variables. We will not have in three variables. So in one variable there is no problem. You need to have just one variable, one equation, and you are good to go. You will have your answer in just one or two steps. But when we have two equations, so sometimes we can have like unique solutions, sometimes like no solutions, sometimes infinitely many solutions. How to figure that out? That is what I am doing here. Okay, now we have this pair of equations. If we have a1 over a2 not equal to b1 upon b2, it means the pair has a unique solution. Unique solution. Unique means only one solution. Only one solution. So for example, we have 2x plus 3y equals to 10 and 3x plus 2y equals to 14. What is the ratio of this? So you can say here that a1 upon a2, I mean the ratio of the coefficients of x, that is 2 upon 3. What about this? b1 upon b2. It is 3 upon 2. Clearly you can see that these are not equal. You don't have to go to this. Once you find out that these are not equal, you can say that a1 upon a2 is not equal to b1 upon b2. It means the pair has a unique solution. So this is unique solution. This is the case of unique solution. Now, second situation. When we have this is unique solution. Okay. When we have a1 upon a2 equals to b1 upon b2, but it is not equal to c1 upon c2. Okay, first write equal to, then we will come to not equal to. If all the three are equal, then this gives us infinitely many solutions. For example, we have 2x plus 3y equals to 10, 4x plus 6y equals to 20. Here you can see that a1 upon a2 is 2 upon 4. If you simplify this, you get 1 upon 2. b1 upon b2, that is the ratio of the coefficients of y, that is 3 upon 6. If you simplify this, you get 1 upon 2. And now this c1 upon c2 is 10 upon 20. If you simplify this, you get 1 upon 2. So all these are equal. So you can say here that since a1 upon a2 equals to b1 upon b2 equals to c1 upon c2, it means we have infinitely many solutions. Many solutions. Okay, infinitely many solutions. In this, we had this situation here. If you look at this, This upon this is 1 upon 2, this is 1 upon 2, this is again 1 upon 2. So we had infinitely many solutions here. Okay. Infinite. Now, what if a1 equals to a2? A1 upon a2 equals to b1 upon b2, but it is not equal to c1 upon c2. Then, so in this case, it will have no solution. No solution. For example, we have 2x plus 3y equals to 10, 4x plus 6y equals to 30. So this ratio is what? 2 upon 4, that is half. This ratio is 3 upon 6, that is 1 upon 2, again half. But this is 10 upon 30, this gives us 1 upon 3. 1 upon, this is 1/3. I mean to say, clearly here, a1 upon a2 is equal to b1 upon b2, but it is not equal to c1 upon c2. It means the pair has no solution. Got it? So we have covered this thing as well. We have covered this. Now, okay, and we will do this thing in detail as well, okay, solving linear equations. But before that, how to draw a graph of a linear equation. Now, graph of a linear equation, we can have two types of linear equations, first in one variable and second in two variables. Both have different, the way to draw them is different. Okay, so first we will draw the graphs of one variable. Suppose that we have to draw x equals to 4. How to draw this? 1, 2, 3, 4, 5, 6, although we need just 4. It's very simple. So when we have x equals to 4, we will draw a graph that is parallel to y axis and where x equals to 4. So this is the graph of x equals to 4. X equals to 4. Keep in mind, okay, again one more. X equals to -3, -1, -2, -3, -4, -5. So x equals to -3 is again this. X equals to -3. Okay, so is it clear now? One variable in, when we have x equals to something, when we have x equals to something, it is parallel to y-axis, parallel to y-axis. When we have y equals to something, for example, y equals to 2, how to draw this? So 1, 2, 3, 4, 5, y equals to 2 should be this. This is y equals to 2. What about y equals to -1? So -1, -2, -3. So y equals to -1 is this. So when we have y equals to something, these are parallel to x-axis. So this is how we draw the graph of a variable. Graph of a linear equation in one variable. Okay. Now we will draw the graphs of linear equations in two variables. Let's draw a graph of a linear equation in two variable, x plus 2y equals to 4. So how to draw it? What we need to do, just make a small table x, y. Best is put x0, get y, and put y0, get x. If we put x0 here, we get 2y equals to 4. It means y is 2. So clearly y is 2. Okay. So when x is 0, y is 2. And when y is 0, okay, again we are putting in this equation, when y is 0, then what is x? X plus 0 is 4. That gives us x equals to 4. This. Okay. So when x is 0, y is 2. When x is 4, y is 0. Now mark these points here. When x is 0, y is 2. Means this point. X 0, y 2. And when y is 0, x is 4. This point. And this is the... And this is our equation. X plus 2y equals to 4. Let's take another equation. X plus y equals to 3. Again, make a small table here. Now put x0. If you put x0, you get y equals to 3. I mean, if you put x0, you get y equals to 3. And if you put y0, you get x equals to 3. So now mark these points here and then we will draw a line. So 3, 0 and means x0, y3 is this. And x3, y0 is this. So the line is... Now one thing you can notice from here, that this is the point of intersection. At this point, these lines meet. This is the point of intersection of these two lines, these two equations. And therefore, this is the solution of this pair of equations. Solution. And what is this? This is one, this is x is 2 here and y is 1. This is the solution of this pair of equation. So how did we solve this? We solved this pair of equations. I mean to say, suppose that you have a question that solve x plus 2y equals to 4 and x plus y equals to 3. Solve this pair of equations graphically. So this is how we solve it using graphs, and this is called solving the pair of equation graphically. There is another way to solve, which is called algebraic way to solve, and there are also different ways to solve. But how to solve using graphs, you can see here. Okay, so at the point of intersection, we can, this is the solution of this pair of equations. I hope you understood this thing. But keep in mind that since we have only one point of intersection here, that's why we got unique solution. This is a unique solution, just one solution, only one solution. Okay, now what about the graphs that are not intersecting at one point? Now we have two more pairs of equations. First, this. If we draw, if the question is solve this pair of equations graphically. So how to solve this? So we will draw this equation and it is this. If you draw this, you will get this. But if you draw this, you will again get the same. Alright, if you try to draw this, you will get this. But if you draw the second equation, you will get again the same. So we can say that these equations are overlapping each other. This is one over another. Okay, something like this. One over another. In this case, how many times these equations, these lines are touching each other? So they are touching at every point. It means they have infinite solutions. Infinitely many solutions. And in this case, lines overlap. So when lines are overlapping, we can say that we have infinitely many solutions. But in this case, when we have this, now we have to solve this pair of equations. So if we draw the first one, so we will get something like this. And if we draw the second line, second equation, second linear equation, we will get this. So these lines are not touching each other and they are parallel to each other. They are not gonna touch ever each other. It means they have no solution. And such pair of equations are parallel. I mean, if we draw these lines, we are getting parallel lines, and when lines are parallel, the pair of equations have, or the system of equations have no solution. Got it? So this is how we solve the pair of equations graphically. Okay, now how to solve them algebraically? Solving pair of equations algebraically. Okay, suppose that we have 2x plus y equals to 4 and x plus y equals to 3, and we have to solve this pair of equations. So there are several methods that we use. First is called substitution method. Second, elimination method. Substitution and elimination, I will teach you both. First, substitution method. In substitution method, we substitute one, to say, for example, this is equation, okay, suppose that this is equation number 1, this is equation number 2. From equation number 1, we will write y in terms of x, so y equals to 4 minus 2x. This y we will substitute in equation number 2. So we have x plus, and in place of y we will write 4 minus 2x, that is equal to 3, minus x equals to 3 minus 4, minus x equals to minus 1, and x equals to 1. I hope you know how to solve this thing. Now we have x equals to 1. We will substitute this x equals to 1 in this equation. So we will get y equals to 4 minus 2 into 1. 4 minus 2, that is 2. So we have got our answer, x equals to 1 and y equals to 2. This is called substitution method. Now elimination method. In elimination method, we make sure that coefficient of one of the variables are same. And here we have this thing, we already have the coefficients of y1 in both the equations. Same. So we have 2x plus y equals to 4 and x plus y equals to 3. Now pay attention. This is plus y, this is plus y. And we have to cancel it. How to cancel it? Because they have the same sign, so we cannot cancel. That's why we need to change the signs. So this is plus, this becomes negative. This is plus, this becomes negative. And this is plus, this also becomes negative. We will cancel these. 2x minus x, because this is 2x, this is minus 1x, so this becomes x, and this is 4 minus 3, this becomes 1, so x equals to 1. And now we can substitute x equals to 1 in any of the equations. If we put in this equation, we get 1 plus y equals to 3, that gives us y equals to 2. So we have x equals to 1 and y equals to 2. So this is called elimination method, this is called substitution method. All right, and one more type of questions. One more type. Sometimes you may have questions like, for what value of k 6x minus ky equals to 8, and the second equation is 3x plus 2x plus 3y equals to 20. For what value of k this pair of equations have a unique solution? Unique solution. So you know that for unique solution, ratios of coefficients of x should not be equal to the ratio of coefficients of y. If you we can cancel this. If you cross multiply, this is 9 minus k, and what do we get? k is not equal to minus 9. So this is our answer. I mean, for this system of equations will have unique solutions. K should not be minus 9. It can be anything but minus 9. So, we do these questions like this. Oh, all right. So I hope, I think I have covered most of the things. And well, of course, we will practice so many questions in upcoming videos. I hope you found this video useful. Give me your feedback, suggestions in the comment box, and subscribe to this channel and share with your friends. See you in the next video. Take care.